So, hello to anyone who's watching. Probably it's only going to be me. So I'm streaming and recording at the same time for documentation purposes. The idea of doing these streams, maybe that's the only one ever, maybe not, is to document my progress with coding Changelogrex, which is an Elixir Phoenix LiveView app, a web app that I'm writing mostly to learn more about Phoenix LiveView, since I know enough about Elixir to get some things done. I began writing this app back in August, and the idea started with an itch I had to scratch. The itch was that for quite a few years now, because I'm running many computers with Debian Linux, and some of them have rather, I wouldn't say exotic, but they have configurations that are not for a desktop. I have run into a couple of issues. One was with some Seagate external USB hard drive that had an issue with the controller. Another one was with my Ryzen 5 3600, which used to crash under zero load. And so over the years, I've gotten into the habit of getting the kernel from kernel.org, compiling it, making binaries, and running always the latest kernel just for fun and out of curiosity. And this started with WireGuard. That's the first time after many years where I found it useful to say, well, okay, I'll run a custom, I run a kernel, a mainline kernel to get access to WireGuard, which is something that I had been running as a kernel module before it was mainlined into the kernel. And since then, I started to get in the habit of looking for issues on the Bugzilla of the Linux kernel, tracking some issues and finding what was working, what was not working. And I kept coming back to those issues a few times over months to see what the progress had been, especially regarding this Seagate external USB hard drive. That was a bit of a pain in the ass because it was eventually fixed, but it was a hassle because every now and then the hard drive was dropping off the connections. It was like, it looked as if it was disconnecting. Eventually it was fixed, and I found how it was fixed and the fact that it was fixed from the Bugzilla. And then I actually went and found the changelog. In the changelog, I found the commit that fixed the issue. The idea is the following, is that so many people who dance around the Linux kernel, they have access to the kit.kernel.org, the Bugzilla, whatever tools they use professionally, let's say. For all of us who are consumers of their amazing work, yes, we can browse the same sources, but to get a quick overview of what has changed in the recent kernel that you might want to build, typically you go and look at the changelog. And if you look at the changelog, you go typically on kernel.org, where you found, oh, nice. Am I running the latest one? No, so there's a new one I could get. So 6.7.4, you look at the changelog. And the changelog sometimes is huge and sometimes is much smaller than you expect. This one, for a patch release, it's quite big, yeah? So probably many megabytes. And that's the address. So I wonder how many lines it is. Interesting. It's not getting, okay. We're talking about 10,000 lines. And who knows how many commits that is. If we search for the word commit in the changelog, we're not going to find only the commits that are in there. We're going to find also upstream commit references, any other occurrence of the commit. So we could go and basically grab this one of the regex. So let's see. Okay, we can do grep -v upstream. This will leave us with caused by. So let's say that we're going to be off by a few lines. Talking about 400-ish commits. Now, all those commits here that you see, They have a special format that I follow. Not usually, you always have commit and the hash, the author, the date, and then you have the body. The body have all those tags, link, tested by, link, and you can have multiple entries of some of those tags. This is always the head commit, so this describes the version, and there's just a bunch of tested by and links here. On the other hand, on everything else, and interesting that encoding here is broken. Okay. So in any case, you have the body, and you have the actually this is the title. You could call this a title of the commit, and then you have sometimes what the upstream commit of that is, then the body, so the text description containing code sometimes, and then any other tag that has been used to describe it. So you have all that bunch of stuff here, right? What I did back in August or September was I coded a bunch of functions not released as a module on Hex, which is called Changelogrex. And what this does is that it offers functions to get those files from cdn.kernel.org, get a changelog, parse it into those separate commits, create structs out of those, and then basically turn it into structured data. So it's basically a bunch of parsing functions. And what you can do then, you can take a commit and process it in parallel across all the CPU cores and the threads. And then you get those kind of structs, the changelogr commit struct, for example. You can see that you have the kernel version, so the changelog it came from, the URL where we found this, the timestamps, the commit. Now it's different, but this is the hash, the body, and you get the body, and this is basically the text here, which is a whole bunch of stuff. And when you run it through a processing pipeline across all the CPU cores, you extract all fields, so it's like a reducer, and it consumes the body, the structured data. It finds the body by parsing it with regular expressions, and it extracts those and stuffs the struct. For example, tested by, you see there is quite a lot. Suggested by, nobody, and so on. Also, who signed it can also be multiple people. So this is Changelogrex. Elixir software often has X in the package title, so it is Changelogr, X for Elixir, and the joke is it's the Linux kernel changelog king because Rex, whatever. Okay, that's a silly pun. In any case, so that's what a changelog looks like. Not every changelog looks the same. So if we go to 2.x, so there's no such thing. The 3.x, yes. I think it starts from 2 point something. The commit format to look like this, because before that, for example, let's say 2. So when did I start? I started with Linux with 2.0.32. 2.0.32. That's so no changelogs here. No, maybe there are. Who knows? Yep, no changelogs here. Let's take this one, 2.0.40. A very different format. Of course, back then also the number of people who were working on the kernel was drastically smaller. You can also take a look at the number of different names compared to what you have in a modern kernel. And this is also something that I intend to explore with the software I'm building. So in any case, ideally I would parse those, but really who cares now about 2.0 or 1.3? The idea is to be able to give people a tool to explore the changelog of any new kernel that's being released. And most importantly is to be able to give users the opportunity, the possibility to subscribe to different topics. What do I mean by a topic? Let's take a small one. Let's take 605. So do you see this one, CLK tegra something. This is the beginning of the body, and this is always parsed as the title of the commit. And it can have, from my quick analysis, can have up to 3 topics here. So it's always topic, colon, topic, possibly. I mean, sometimes it has a topic, sometimes it has no topic. From my quick run on many kernels, it has up to 3. For example, here you see that it talks about this commit with the topics PWM and tegra, and then the actual title. So what is the idea? The idea is that if you're interested in a topic, for example, PWM or tegra, or maybe you are interested in I don't know, BTRFS. It's something that I use a lot, or WireGuard or whatever. When you have those changelogs and you parse out that data, and you can you can assign a tag to the commits that are related. The idea is to be able to subscribe as a user to a topic. So you have an account on Changelogrex, and when a new kernel becomes available, the system will automatically fetch it from pub, so from cdn.kernel.org, store it, process it, split it, tag it, do everything. And then if you have subscribed to this topic, you will get a notification. And I will also set up so they could get an email saying, hey, look, a new kernel available, there are new commits for the topic. So you can look at it as a tool to be able to explore the commits in case you're interested for whatever reason, and to be able to stay on top of the topics you're interested in, because maybe you're a developer, or maybe you're a power user, or maybe you're just a hobbyist and you like to follow what's happening with your AMD, DRM, Radeon, whatever, AMD GPU drivers. And finally, just for fun, since we have the data eventually in the database, we can also see rankings that are already available, like who has most commits, who committed most, who mostly signs off, kind of have a structured data about the changelog itself, so statistics about the whole changelog, extracted from the data, the structured data that we parsed out of the different commits belonging to that changelog. And maybe over time, I can also plot contributions or topics being active. Maybe you can plot, I mean, it's probably not that difficult to say, just count how many times the topic X appears across the last however many kernels, across how many commits, and then see how topics wax and wane, and kind of look at the contributions to the Linux kernel through a different lens. But having said that, still the most important thing that I wrote this for is for fun, to learn Elixir better, gen servers and all that, to learn Phoenix LiveView really well, to finally understand the LiveView lifecycle, and most importantly, to scratch my own itch of following some topics that interest me. Personally, I'm really interested in WireGuard, even though that's now kind of stable actually. I'm interested in BTRFS, interested in Bcache, KVM, AMD GPU. Yeah, that's basically it, because I'm running quite boring hardware now, with lots of ThinkPads and think centers, and yeah, nothing special. In any case, so that's where the motivation comes from. Now, for many months, whenever I was developing and testing these functions, which you can, by the way, find on a previous version of which you can find on GitHub, I used to hit this address, cdn.kernel.org, and I was getting those changelogs every time and consuming their bandwidth and my time, because unfortunately my ADSL connection, yes, it's still ADSL, is quite slow. I was consuming a lot of time to test. So I would wait there until the Linux kernel 6.1. So 6.1, if you see 6.1, the changelog 6.1 would download. That's like 14 megabytes. It's not much, but when you have a 15 megabit downstream connection, it takes a while. So I would wait and wait, and then if I wanted to try something new, I would wait again. And what I've done here over the past few weeks is I mirrored this entire tree from cdn.kernel.org, and I got all the changelog files and the index.html. I don't have the tarballs or the signatures. I keep only those changelogs, so I serve it locally, and that's the address I'm using to be able to not waste any time and Linux guys bandwidth with those requests. So this downloads it, which we don't really care about, but the idea is to be able to access programmatically from Changelogr. What does Changelogr look like? So let's see. So initially I started with, it used to be called Changelogr, not Changelogrex. So it started off as a bunch of modules. For example, the parser, that's the most important one. Or the fetcher, the fetchops struct, I'll explain. So the fetcher, those are the functions with which I'm getting the files from kernel.org, and the parser. So how many lines is that? It's 300 something lines, and yeah, so total, let's say 600 lines or 700 lines of Elixir. It's nothing crazy. It's also nothing difficult, I would say. Let's start with the parser. Basically, here we have two structs: the commit and this is the what describes a commit. And actually, this is not a struct, but this is a list of fields that appear in the text in the body, and that's what we're parsing out. There are some things to fix here. So I know this is issue 2, which I've created, which is it's that sometimes what you have instead of CC, you have CC. So I must fix so that I can accommodate different spellings, capitalizations. But this is not right now not the most important part. In any case, what we have here, we have basically a parser module that well, let me see where I have it showing the changelog. Okay, see, kernels, here we go. Let's see where I have it. No, fetcher, so it's in fetcher. This is the one struct. So there are 3 structs here being used. The one is the changelog. The changelog is described by a kernel version, a URL where we get it from, a date, which is, this comes from the directory listing. So it comes, this is the date, this is the date. The timestamp, so when it was fetched, it's basically just for record keeping. The body, that whole bunch of text that might be up to 40 megabytes or 60 megabytes. And a list of commits. That will be a list of structs, of commit structs that will stuff with the result of the parser. Then we have the fetchop. The fetchop is probably in the end not really needed. The idea is to have a struct that keeps the data of the fetching operation, so that I can have a record of at that date I fetched this file and it was success or not, to keep some logging in case there's an error or something fails, because otherwise, because this was meant to be running passively with a cron job essentially 4 times a day, checking the Linux kernel directory to see if there is something new, since there is no webhook. The idea is to have it running automatically, and if it fails, it will send me a message. So I need to have a struct, I thought, to keep that. What this also does is it's a struct that contains the listing of changelogs and their hrefs, the dates. So basically holds the result of this get request. So all this and that and the link. So that 6.0 is from this date and it has this link. Might not be needed, might be a nicety that eventually languishes. So in any case, that's the third struct. So we have the changelog, we have the fetch operation, and then we have the commit. The commit is the one I showed earlier, which is the most important one, because this is the struct that contains our data after it's been parsed, after the changelog has been parsed. So the parser module, what it does is it contains a list of all fields. So it's a map, right? So it's a key and the value, all the values. So here, so the values a list because this can appear in different ways. And I also say, look, there are some fields that are singular, and there is a convention for the indentation that is 4 spaces. If you look at a commit. So if you look at this, for example, this is 4, and it's always been like that apparently. But I want to unindent it to show it nicely. Now, it is a bit of a spaghetti code when I come back to it because it was written over a few weekends and evenings. And usually what I find is I tend to put the helper functions towards the bottom of the file. So let's start with this. One thing that we have is how to describe the kernel version of a Linux kernel. That's for validation purposes. So when you pass it a struct of major, minor, and patch, it will return the properly formatted. How to parse it and how to validate it. So those are just helper functions for the validation. The heart of the module is this function, which seems deceptively simple, because it's a function where you pass basically all the fields of a commit with a body, and then what it does is it takes all the fields, so all the fields, it iterates, so it passes it on to, so it takes all the keys, and then it runs enum.reduce on the commit, and it uses this reducer function here with an argument of k. This is the field, and the ACC is the accumulator. So the commit, which is the struct, starts off as an empty struct with nil values, and it gets passed through multiple successive calls of the extract field function with this, and the accumulator just accumulates the parsed data. So in the end, you end up with a struct that is filled. Every time data has been extracted, the field has been extracted, it is removed from the body. So the body begins as a long text like this. Begins like, let's say it begins like this. So when you say extract all fields of this commit, then it iterates over the keys, it finds the link, so it removes this and that, stuffs the commit struct. Then these 2 lines are removed. Then what remains gets used again in the call with the updated fields. All the tested by values are removed, so then you end up with this and that and signed off by. And then when it reaches the signed off by key, it removes also the signed off by. So in the end, the body becomes just this here, Linux 6.0.16, because also stripped the new lines and I unindent. And all those become part of the struct. And after you have the body, You process it, and what is process body? I used to do a line unwrapping, but I realized it's highly crappy because what it does is it cannot differentiate if you just unindent and remove consecutive new lines. You break up the formatting. The idea was to not have fixed width font and this ugly format like a plain text file, like opening it in Notepad. Um, but it doesn't work well because you do have text and code mixed in there. Whoops. So where is, so we have here process body. So define process body of a commit. So you pass the commit, the body is you get the body. You compile the regex for the indentation to remove it, which is silly. And we basically remove the indentation, we trim it, we split it. So what we do is we remove successive, I think we remove the new lines and we trim. Yeah, good luck now remember what this does. Huh? So when I wrote it, I understood what was happening here. What this does, it makes it beautiful. So it makes it look good. It removes all the successive double new lines, I think, and it trims it from the end and removes spaces after it unindents. Yeah, that's what happens when you code something many months ago. My current self is not doesn't know anymore what my past self did, but in any case, it works. And this is my older attempt, which at some point I will remove. It's that I was trying to make it look even prettier by making into paragraphs of text by unwrapping text lines, but this broke the code formatting. In any case, after you're done, you take the commit that you got in the beginning, you put into the body attribute the new body, which is this. So that will be new. And yeah, so I think I got why I'm doing this. It's because I'm doing pattern matching and I'm taking all the whatever. So then you take the body, you put in the be new, and then you merge it with, you merge in the topics that you extract from the title. So extract topics from the title is another function. All those are regex basically, where you extract up to three topics, the primary, the secondary, maybe a tertiary one, from the title, separated by columns. And I hope it works. This is something I haven't tested extensively, but there's a whole bunch of stuff that happens here, which I don't remember how I'm doing it. It's basically text processing and turning into a map. But it looks very advanced, but it's basic Elixir. Might not even be anything crazy. In fact, I mean, it would be interesting to see what explain this, what ChatGPT thinks. See, so I mean, you can say whatever you want about LLMs, but this is a fantastic use case. Like you can come back to code that you don't even remember how you wrote, and it will work. It works just fine to explain. So you don't need to write so many comments anymore. Let's go back. So what else is happening? We extract topics, we process the body. This is just different processors for single fields, cleaning lists. And that's the meat and potatoes of the whole module. This bunch of stuff here. Extract field. First of all, extract field with a commit. So you basically put in the commit ID, the hash. And then the different invocation of the same function with the same arity is when you have upstream commit. This is a different function to process this. Then extract field, that's a generic one. And that's it basically. So this for anything else other than the commit and the upstream commit, what you do is you apply the same function calls, the same approach with regex. You compile a regex using the name of the key up here. So this, right? So you say, make me a regex that will replace suggested by colon, remove that and extract the text that comes after it. That's the regex. So what does extracts it, see if it's nil, and then makes a nice list if it has multiple values. That is the parser. That is not very complicated. It looks a bit complicated because there's a whole bunch of pipelined operators, but not very difficult. Overall, just Elixir, and it was fun to write. Now the fetcher. The fetcher has functions for fetching a changelog, so it uses, what do I use? I think I use Finch. Let me see. I'm using Finch to perform those requests. So let's find it again. Fetcher. Here you go. It's a very simple helper function, HTTP get. We have a guard here to check that it's a string, the URL, just since we are using a dynamically typed language, right? So we use function guards to make sure that the invocation is right. I'm still not using specs here, those type specs. In any case, we build a request, we request it, we see whether it comes back as okay or error, and when the status is 200, we return the response. And what else we do? I have helper functions where I can turn a kernel version to a URL so that we automatically find out this. So when you say, oh, okay, what is the URL of the changelog of kernel 6.0.16? So then it returns the URL. In fact, why don't we try it out? Let's see. There we go. So we said it's, which one is it? Let's see. Kernel version to URL. So we're in changelogr dot fetcher dot kernel version to URL, and it's for version 6.1. 6.1 is a big one. See, it uses different helper functions to take the base URL, merge it with a file name, return a string. If we try 6.1x, yeah, it doesn't validate it. So maybe I could implement better here. Let's say 6.2, 6.999. It doesn't. Okay. So it validates it. It validates it somehow. Kernel version to subdirect URL. Okay. It works when the string is correct. I need to improve the error handling. Let's see how it actually works. So we'll follow what the README says. First one is changelogr.fetcher will fetch available, all available from let's take the 5.x. What it does is, it will go here. It will go here. And it will make a GET request to get this, parse it, get the names, the timestamps, and the hrefs. What does it return? Since it was successful, return OK, so we'll pattern match on this. This is available. So not available. What is available? Available is a map that contains a fetch op struct. Remember the fetch operation struct? So available. The URL we got it from, so you see it constructed properly when we received it. So it's in UTC. So I'm in Athens, so UTC is 1551. The state is 200, fine, of course, because it was successful. And we got the body. This is basically this. This is this here. Right? This is all stored in the fetch struct. And then it's being parsed out by extracting the kernel versions as the keys of the hrefs, hrefs attribute in this map, and the link, so this coupling address equivalence, right? So this here is here. And then it also extracts the dates. Now, this is not very helpful, so we'd like to convert it to a list of changelogs. So we said what the changelog has a kernel version, which is this one. It has a URL, which comes from this place. It has a date, which comes from that value. It has a timestamp when we got it, which we haven't gotten yet, so it will be nil in the beginning. A body, which we haven't extracted, we haven't downloaded. We don't download the change. We just download the listing to see if there are new ones to get. That's why I wrote the fetch up module. And the commits, which are going to be nil because we haven't yet parsed and stored any. So we'll turn those into what I call fetchables. So again, we pattern match. Okay, fetchable equals changelogr.fetcher. So this is a fetch up to changelogs, and this is we called it available earlier. So what we have now, we have fetchable. And fetchable is a list of changelog structs that have been initialized based on the data of the fetch operation, but haven't yet been fetched. All of them have a nil timestamp because we haven't recorded that we fetched them since we didn't fetch them. We don't have a body because we didn't fetch them, and we don't have commits because we didn't fetch them or we didn't process them. So now we need to fetch them. So what do? We use enum.map. If, for example, let's make it even simpler. Let's take, so fetchable. Let's take fetchable, let's take enum.add. Let's take the 15th element, 16th element actually, right? Because it's 0 indexed. Let's take this one. So what we want to do, we want to feed it to this function, changelogr.fetcher.fetch changelogr.fetcher.fetch changelog. So that will fetch the changelog from this URL, and it will stuff the body, so the content of the text file, into this attribute, and it will record when it was fetched. See, here's the commit. And here we have a timestamp and the body, and commits are still null. Let's continue this. So I want now, so now this gives me this, okay, comma, let's call it CL, what is it, 503. It's 503, same 503. CL 503 is this one. And now I want to extract all fields. So I will feed this into changelogr.parser.extract all fields. What am I doing? That's wrong. No, I need to split it into commits first. Parser.changelog to commits. See, now out of this text here, this here has been split. Actually, no, this text here. No, still not. Still not. Wait. CL503. CL503 has this body. So the body, and it's a long body, will get split into different commits. So when I do this, I'm getting a list of commits. And you can see that every commit has the kernel version. Apparently this has no title. Not all of them have a title, which is weird. No. See? I even forget how it works. They don't have a title yet. So what we do is that we store the body. So all of them have the kernel version, the changelog URL, so where it came from, when it was fetched, we get from the changelog, the timestamp of the changelog, we get this from the changelog, the commit, which is extracted, is the hash basically, but still not parsed properly, and then the body of the commit that came from the changelog. And all the other ones are nil because we haven't parsed it. So okay, we have now, this is commits 503. Let's say this is the list of commits from the changelog. And I guess io.inspect commits 503. This is also a tuple, so I assume it's a tuple. Yeah, it's a tuple. So this is a list actually. And one day I need to learn how to do monads so that I can not have to with okay, error, and all. Anyhow, we have now a list of commits. These are the commits of the Linux kernel 5.0.3. Let's take the 6th one. No, that's the 7th one. Okay, so you see that is nil. And then we'll take this and we'll feed it through changelogr.parser. No, commit, extract all fields. Boom, that's the end result. And I know it looks complicated. I know I'm losing my train of thought because it's been a while. I made this into like a pipeline to make it very structured because I want to be able to process things in parallel. So I split in different functions, but this is the end result I want to have. And one thing that I don't like, at some point I think the way I'm doing some things breaks the struct, and hence I get this underscore struct key in here that describes which struct is coming from. And it has to do with, from what I remember, with the serialization of the data. Not everything can be serialized. I think it's because of the, I don't know. I think I asked ChatGPT and he told me why not. Let's see. Map. Struct. Yes, so that's why. It's not the protocol not implemented for this one. I'll figure it out one day what I fixed. what I need to fix, what I broke here, but it's not that important right now. But it does. I do want to get to the bottom of this because it is a gap in my understanding of how this works in terms of in Elixir. So in any case, we have, when we do this, we get the end result for one of the commits in the commits of the changelog of kernel 5.0.3. So now I want to do this for all the commits of this kernel. And what we'll do is we have the commits. Instead of doing enum@, we'll do enum.map. We'll map the same function to the to this. We don't need to do it with a pipeline operator, by the way. It's considered an anti-pattern to do it when you only have one feed. So map enumerable, that's commits 503, and what we do is we use this function here, changelogr.parser.extract all fields 1. Here's what will happen now. Results equals, what is results? Len results. Length, too much Python in my past. So we have 44 commits in here. Let's look at results. Let's look at the 16th element. Here you go. You can see how the body has been parsed. So let's take map.get body, right? And then we can do io.puts. There you go. You can see that the structured data from before has been extracted, and it has become this. So reported by, reviewed by, signed off by. And that's basically, that is the backend, that's the Changelogr modules to do the fetching and the parsing. The README here now of the library, as I released at some point on GitHub, it's different how it's that it describes how to do this for all of those kernels. So we got the fetchable, right? What's fetchable? We got the fetchable of the entire 5-point-something series. So now what we'll do is we'll fetch them in sequence, one by one. And don't worry, I'm not stressing the cdn.kernel.org, even though it has a varnish cache, so whatever, no big deal. But the thing is, I have a slow internet connection, so I'm going to get all the changelogs of the kernel 5-point-something from my local HTTP server. That's basically python-mhtp serving that from a directory. And we'll first fetch them, and then we'll parse all of them in parallel. So changelogs equals enum map. We'll apply this on. We'll apply on fetchable. We'll apply the fetching changelog, the fetching function. Fetcher.fetch changelog /1. Let's say arity here. So, and now let me show you, because I have the, let's see. So this is, what is this command? Nothing special. So you see cdn, so mdbc tag, that's my btrfs drive. cdn.kernel.org, what is in here? Pub. It's basically the mirror, the local mirror of cdn.kernel.org, at least the files that I care about. So, and what do I do? I do just Python 3 -m http.server. So I'm just serving that with this path, and that gives me this here. In which case, this command will fetch all of those changelogs. And by the way, interesting thing that I just realized is there's an exception here that I'm not dealing with. this one, the -rc3. My modules do not account for this, but seeing as this is rather rare and nobody really cares about such an old version, I won't bother to fix it because this is a waste of time. In any case, let's see what the server responds. You'll see the GET request coming in. See? Got everything, and they ended up as changelogs. And the changelogs, this is a list of tuples, and the tuples are okay tuples, right? So k, comma, whatever. So changelogs, if I take the first one or the second one, it's a tuple of okay, so it was fetched, and then the changelog as before. So we're done with fetching. We're done with fetching. And now we want to get actually the ones that are okay. We can also check which ones of those are not okay. So you filter the changelogs with this function where you take key comma like status comma changelog, and you only return those for which the function status is not okay. Right, so this was useless. None. So all of them have been fetched correctly. If I now do is okay, and I pipe it to length, we'll get how many of them we have. 970 commits. No, sorry, 970 changelogs. Each one of those can have many thousands of commits. So now we have all the changelogs. And this is a rather huge data set because in every one of those we have those potentially megabytes. Like one of those has 5.1. Generally, the major releases are horrible in terms of number of commits, so they're huge. Multi-megabyte, like 15 megabytes. Which one is an M? 5.13, 15 megabytes. So we have all those data, we got them here in memory. And actually, I wonder how much memory do we use? So yeah, it's quite a lot, right? So which one is it? Is it this one or is it this one? I wonder. Beam, SMP. I wouldn't know, to be honest. One of those. We have lots of data and memory. So if we go to MNT basic data CDN. Why don't we check it? $434 megabytes. Yeah, the memory that you saw in HTOP it also includes, because I'm running now the Phoenix LiveView as a server, that also is in memory. So that's why we have more than 400 something. So we have all those data we have in memory. Just a moment. Just a moment. So we have those data now in memory, all those text files, they're in memory in those structs. And now what we want to do, we want to take each one of those changelogs, split it into commits, and then process the commits and turn them into, parse the bodies of those commits. So we take the changelogs, and all of them are okay. So we want to extract only this, only the changelog. So we don't care about the status. But we can also do this. We can do, since we know it's okay already. Okay, comma, changelog. Just return the changelog. Okay, so now we have a list of changelogs. And for this, we'll apply this function, changelog.commits. And it's we do it with string, doesn't really change much because anyway it's only one invocation. So we could also do async map, right? Or is it? Oh no, async string, that's true. So we do enum, and after we finish, to list. And let's see how much processing power this will take. Done. That's it. We just parsed all those. So now we have them, and we parse them into commits, so we split it. It's not an expensive operation. So after we get them, we need to get all those that are okay. So we'll apply this function, we'll filter it for those that are okay. Which are all of them, I guess. And then we'll just extract the values. We don't care about the status because we know it's okay. This is a commit. That's it. So what do we have here? We have the result. So for every changelog, we have a tuple saying the status and the list of commits here. This is a list. But I don't care about the status, so I will filter it. I will filter for those that are okay, which are all of them. And I will again just take the values. So we have lists. We have a list of commits. And since I do not care to have it structured by the kernel version or the changelog, I will flatten that list. And now what I have is a list of commits. So we'll name it commits. We'll let it run one more time because we are now done. We have almost done. We have a list of commits with bodies that still need to be parsed. And that's the expensive operation because we need to run all those regular expressions across it. I wonder now, for all Linux kernel 5 point something changelogs, how many commits have there been? So I do length of commits. Almost 500,000. And now I want to parse those. So if I take the first one, this is what it looks like. See, it's nil, 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 because we have the body. Again, this is the head commit, so it just contains the Linux kernel version. But if I take commits, pass it to enum.add, let's take the sixth element, you can see that this is the body, and author will get here, and date will go here, and so on. This is what we want to do with the function extract all, what is it, changelogr.parser.extract all fields. So I want to apply this function across all of the 440 something thousand commits. So what do? I take commits and I do task.async string, because I want to do it across all of the CPU cores string. I will apply this function, and I will convert the result of this to a list. And then again, because this always return, I programmed my Changelogr module, the parser functions, to always return OK or error. So I will get tuples of OK, and I just want to get those for which the processing was OK. So I'll map the OK ones. I want to extract. And by the way, this will actually fail, because if one of them has an error, so this is not the right way to do it. The right way to do it is to enum.filter and get first the OK one, the status or whatever. Status equals OK. Oh no, this was stupid. Now it's running. See, something is wrong. So not all of them. And we're back. Hello again. We're back because I did something. I think I was very close to having running very low on memory, and what happened was I'm not activating a swap. As you can see here, it's a swap, but I don't know why. But it's once I run out of memory, it crashes. And I think I need to fix I need to set the early out of memory killer. But in any case, my machine crashed. And I rebooted, so I lost my state. Where were we before? So we had the commits, right? We had almost 500,000 commits of all the changelogs, of all the kernels, of the version 5 of the Linux kernel. And before the video cut off, I ran a line that was, let's find in the history. So I guess I lost it when it crashed, right? So what do we have those? No? We have the commits. This is a flat list of all the commits. And we said we want to do commits. We want to do task.async stream. So generate a bunch of asynchronous tasks by passing every commit through the extract all fields function. And then we'll turn this into a list. And then what I want to do is I want to filter that list. It's going to be a bunch of tuples, and I want to get a list where it's a list of those where the status, regardless of what the content is, where the status is OK. And then after these are done, I want to do enum.map. So I want to status, commit result. So I want to just get, well, basically that. So we call it processed. Now, let's see what happens to my CPU and RAM when we do this, when we run this. 3, 2, 1, go. So I guess RAM is creeping up. Yes, what's going on here? See this? Right, so that was it. Length processed. So it didn't even run, huh? Very interesting. So I need to figure out why it failed. So this is failing. One of those functions are failing. It's always failing. So we'll do this for the sake of demonstration. Let's do the version 6. Okay, So we have 176 changelogs. Then we do commits equals this. So length commits. So we have far fewer commits. We'll do. Let's try this on version 6. So, running, huh? Let's see how long it takes. That's it. That's it. So, processed. All of them succeeded. So I must improve my parser for the upstream commit reference in the so that it doesn't fail. I need to make it more error resistant. So there is some work I need to do in my library. In any case, we have now all commits. And just for fun, we'll take just the values. So enum.map, we'll do fn status comma commit, and we'll just return the commit. Let's do this again, just for fun. That's it. So let's take now processed. Let's take one of those. Right, so it was not acknowledged by anyone. The body is this one. After we remove that, the CC nobody, the changelog timestamp. So when we got this and where we got it from, close nothing, was codified by nobody. The commit ID is this one. The date is that. Debug by nobody. Right. So we parsed all this, and apparently it fixes something. Signed off by 3 people or 4 people. And that's a title, and that's a row title. So I also store the row title because I've noticed a few times that the title might contain a colon, something like error colon something. So I need to write an extra rule to ignore the error colon topic, because it's not a topic, it's just somebody wrote use this in the title. But in this case, it was that the row title is net HNS3, whatever that is, and that's the actual title that we parse. And we extract here net as the primary topic and HNS3 as a secondary topic, and there is no tertiary topic. The upstream commit is what we parsed out of this. And what else is interesting here? Sometimes, you know, it can be fixing multiple bugs. So it fixes net HNS3. And by the way, since we have this in the database eventually, C1A whatever, I can also make it so that I link it. So let's out of curiosity, probably the C1A this commit is part of the data set we have in memory right now. So let's see processed enum.filter. So we take the commit and we say we select the one where c.commit well, I do it differently. I do string.contains if it contains this. Interesting, yeah? So none of those. So probably maybe it's something from an older one. So let's see. Let's by the way find it. Let's do enum.map. Good. Out of curiosity, so am I using it wrong? I think I am. I think the arguments are the other way around. No, the arguments are correct. Interesting. Okay. Out of curiosity. Right. So apparently this does exist. Okay, let's not focus much on this. In any case, so this is basically, this is how Changelogrex works with a minor interruption. And that's how you end up with the data of commits stored into structs. This is for the backend operation, which as you see, I need to improve a bit, even though generally they work. And what is the idea behind the web app? The idea behind the web app is to make all this available as a user-friendly web UI to be made available for anyone who wants to use it. So it's going to be a free app. Who cares to make money from this? I don't think there's money to be made out of this anyway. So what you get is you get a dashboard. It shows you what's in database. You get a list of changelogs that are already fetched and perhaps processed, and you get commits, which is all the commits that have been extracted and have been stored in the database. In fact, the database is a SQLite database because I do not want to run a Postgres server to do this, and I want to try out to see how SQLite deals with that amount of data because we have quite a lot of data. The way this is presented is you have a bunch of changelogs here and you can add more. If I want to add 5.8.9, you can see that it validates. Right? So every time I type something, it passes it through a function. It does a validation event in the backend. And I can save it. So it was, for whatever reason, it's not working now. As always, the demo effect, as it's called, right? So if I want to show you something, it does work. Maybe it's because I've already stored it. Even though it's fetching it. So you have those changelogs here, and they have been processed. And when you get the list of commits, of course now it's just a flat list. You get the kernel where it's come from, the commit ID, and then the title. The title after the processing where the topics are extracted. For now, the display of every commit is very simple. I just show the body and I link to the kernel, and I have the ID of the commit, and I link it to git.kernel.org because why not? It's stored there anyway. And the nice thing is here you also see the diff, which makes it simpler to get from the commits to the actual code that changed. So I do see a value in doing that. And Changelogrex can help you explore the changelogs and where they're coming from. The commit page is paginated using flop Phoenix. It's a library for doing that. You can see it's quite fast, but of course it's also local. And I've set it to, I think, 50 commits. There will be settings and notifications and quite a lot of work to be done to make it deployable. But interestingly now, what I've been working on is the dashboard. And the dashboard is how I finally understood how to to make the page interactive, the idea is when you are looking at the page, wherever you are, and suddenly the backend fetches, processes, and stores the commits of a new kernel, I do not want you to have to reload to see that new commits are available. I do not want you to have to reload to see here notifications saying, hey, there are new commits that relate to the topics you have been following. So what is the idea? The idea is to turn this into a live component, so the notification, which doesn't exist right now, list of notifications. And this is a live component. This is a live view, and this is a live component. This is also a live component. Let me show you. So here I have the index. This is the dashboard index page. Doesn't matter, this comes from Tailwind, so last 30 days doesn't matter, just a placeholder. And here I have live component that is coming from this module with this ID, and here's so this is the dashboard live commit tile component. This is the changelog tile component. Here's the one, and here's the other. And what they do is they basically, whenever they're signaled from the live view, so with a pub sub, they have a function that basically stores data, fetches, processes, so a new changelog, new commits. While it's processing, it is signaling, sending an event through PubSub. It's broadcasting to the CRUD topic that, hey, there's a new commit, or hey, there's a new changelog. And when the live view receives that PubSub, either of those, it signals the corresponding live component with send update to itself, because the live view and the live components, they are under the same process ID. So it signals itself with this PID with this receiver here, the live component, that there is an update. So here we have the update function being triggered, and that's what updates this, which means I can come here. I can do Changelogr. Whoops, new. Yeah, whenever this happens, it's annoying. How do you escape this in the X? Okay, good. So changelogr.12, I have written this function, and when I write 5.9.9, look what will happen. Okay, it's a bit too chatty, right? I don't need to update this with every push to the database. This was updated and this was updated. See, fewer commits. Boom. And this is logging the PubSub messages. That's the idea behind the Changelogr experiment of mine, which is mostly backend and to learn how live components and live view works. It's fun seeing numbers go up, especially when you load something big like 5.10. So it was not, yeah, see? It's a bit pointless, the whole thing. I mean, there's no reason why you'd want people to see the number go up live, because fine, right now it's local, but imagine that you have 10 or 100 users, like hoping that I will ever have so many users looking at this. You'd have to send so much data every second. And here we might, I don't know why it proceeds and stops. I don't know if it has to do with the SQLite. If you want to see what this looks like, it'll open git DB. Commits. Yeah, this is right. See the number going up. How big is the database? Well, you know why? Because it's not being written to the database, I guess. There's also the write ahead log, right? So you can see the number going up too. Lots of data, and we're turning into an SQLite database. So this will grow rather large. And you can see how long it takes to store them. Now, it takes that long also because of the pub/sub. If I remove the pub/sub messaging after every single commit being parsed and persisted, it will not take that long. This is just wasteful just because it's fun to see a number go up. But I could also have it update the page, so send an update message to itself once it's finished. There's no reason now for doing this. And it could also be that the commits are added and then signals, hey, there's a new changelog and here are the commits, and then you pop a notification up there. In any case, we'll stop here because there's no point in going further. You see now how it works, and I hope to continue working on it during the weekends over the next weeks or months even. And let's see where this goes. There are other things that I've been doing here. I have an idea to use locally hosted LLMs to ask for clarifications, like explain like I'm 5 years old. But seeing how slow inference is on the CPU with Mistral, I don't know if it can actually be of value, because it's faster to just copy paste the body of the commit and just throw it into ChatGPT and say, hey, explain what this means, as I did earlier. So this is Changelogr, Changelogrex. I hope if you're interested in Elixir that you learned something or that you found it interesting. Hope you enjoyed it. Bye-bye.